In this video, we're looking at experimental design. In experimental design, one of the things that we are very interested in is types of variables. So when we're designing an experiment, we're going to have things that we are measuring, and we want to collect data about the things that we are measuring. These things are variables. Variables vary depending on what they are and the type of experiment that we are doing. So looking at different variables, let's look at an experiment. So this experiment is looking at reaction time. So we can investigate reaction time by dropping a ruler and seeing how quickly someone catches it. So with my fingers, the ruler drops. How quickly did I catch it? And we can actually measure that using the gradations on the ruler. So our independent variable is the variable of the person who's trying to catch the ruler. The reason that it's independent is because each individual is not going to change in the experiment, and they're going to have their own unique characteristics that are a quality of the fact that they are who they are. So let's say we have me and we have you and we have your friends. So we have three different people, and each of us is going to have a different reaction time. But in the experiment, we remain constant. We don't change who we are. So our variable is there independently. I can't be you, you can't be me, and your friend can't be you or me. The dependent variable is the variable that depends upon the independent variable. So this one is going to be how far the ruler drops. How far the ruler drops depends on who is catching it and what their reaction time is. So it depends on that independent variable. Another example would be a classic experiment when you're testing the amounts of water on growth of a plant. The amount of water is going to be what is measured, and the plant growth depends on how much water the plant receives. So your independent variable is the water, dependent variable that depends on the water is the plant growth. Your control variables are going to be things that you control in the experiment. So if we're testing how far the ruler is going to fall, we need to have the same position of the ruler above the fingers in each and every catch. So regardless of who the independent variable was in my experiment, they need to start with the ruler in the exact same position as everyone else. And then also the distance between the fingers, because it's going to take longer for my fingers to close on the ruler if they're farther apart. So we're going to have to be very careful to make sure that those are things that are kept exactly constant or controlled in the experiment. Finally, one other type of variable is a standardized variable. And we don't always have standardized variables, but we can. So in our example that we're using with the ruler drop, perhaps we want to standardize the age of our participants. So maybe we want to see if 13-year-olds have different reaction times and what those characteristics are. So we're going to standardize the age in our experiment. And maybe we're going to compare those 13-year-olds to another group where the age is standardized and it's people over 80. So those are just some of the things that we have in experiments. When we are looking at types of variables, we want to, again, we're using these to collect data, and we want to be able to analyze the data, and using a graph is a great way to do that. So here we're looking at a bar graph. Our independent variable is the actual internet browsers that we're using. Again, those are all independent. Your Chrome browser and your Opera browser and your Firefox, those are all separate. We're going to measure how many people click on those. So the number of clicks will depend on the browser. The browser is independent because the Chrome browser can't be the Safari browser at any time. Those two are independent from each other, but they are going to be used to measure our dependent variable. Again, this is the number of users. So your dependent variable, which is typically found on the y-axis, your independent variable is almost always on, it depends on the type of graph. Any graph that you will use, it will be on the x-axis. On the y-axis is where we put our dependent variable. And the number of clicks, again, is dependent because it depends on which browser we're talking about. And then what we're displaying with our bar graph, it's just going to be either the average or the actual number of clicks. And this type of graph does a good job of displaying something like that. In the event, though, that we have sequential data, so data that is continuous, like time. So we can measure time at any point in time. So I can stop a clock at any point in time, and there is actually a measure. So that's what we call sequential data. In this case, time is always an independent variable. It's going to be plotted again on our x-axis. So what depends on the time here, we're looking at velocity or speed in meters per second. So how quickly is something traveling over time? Well, how quickly it's traveling is going to depend on the time that we took that measurement. So again, dependent variable velocity depends on the time that we measured it. Because it's sequential data, a line graph makes sense. Finally, we're looking at statistical analysis. So in science, we don't just draw conclusions. We need to make sure whether our conclusions are significant. If we are saying that something happens more frequently than something else, or that something is we demonstrate that there's a difference between A and B, we need to show that it's statistically different. So here's an example. Let's say that I say that students who spend 30 minutes a day studying vocabulary in the class will get a higher grade than students who spend less than 30 minutes per day, maybe 15 minutes per day, or 0 minutes per day. I just want to say that if you spend at least 30 minutes per day studying, that you'll get a statistically significantly higher grade. So when I measure that, I will see some variation. So I may have a student who studied for 30 minutes and they get they have a 75 in the class. Someone else studied for 15 minutes and they have a 75. Someone studied for 45 minutes and they have a 75. And then someone else studied for 30 minutes and they got an 80, and someone else that studied 30 minutes got a 90. So what I will do is graph those, and I'll find out whether or not the individuals who spent 30 minutes fall outside of what would be the normal average, because we know there's going to be variation. Not everyone who studies for 30 minutes is going to get the same grade. Some individuals who study for 30 minutes will be a little lower, some will be a little higher. There's going to be some variation. So we expect that natural variation. What we're looking for is whether the individuals who studied for more than 30, or who studied for 30 minutes or more, fall outside that predicted range of variation. And if that's the case, then we can say that they are statistically significantly more likely to get a higher grade if they spend 30 minutes or more studying in their class.